Hello everyone, welcome back to the Math UMS class, week number 20. Today we will begin the chapter of measurements with the lesson about the surface area of some solids. And today we will focus on the three solids, a cone, a cylinder, and a sphere. Okay, so let's begin the lesson today. The first solid we are gonna learn is the cylinder. Can you imagine of a cylinder? Can you take some example of cylinder objects in real life? Okay, here are my examples for a cylinder. The milk can or a food can are often shaped like a cylinder. A battery and a drum. Of course, there are many more like glasses, bottles. A lot of things are shaped like a cylinder because a cylinder is quite an ideal shape to contain things. Okay, so now we will come to the anatomy of a cylinder. A cylinder has two bases. There are two circles and it has an axis, which is the path connecting two centers of the two bases. The base radius is the radius of the circular which serves like the base, and the height is the distance between the two bases. Okay, so these are some key factors of a cylinder. And now we will come to the formula to calculate the surface area of a cylinder. The total surface of area is calculated as the curved surface, the surface that wrap around the cylinder. Can you imagine that? Just like when you wrap a gift, the curved surface, and two circular bases. Two bases, the top base and the bottom base. And the formula for the curved face is 2 pi r8. 2 times pi times the radius and times the height. 2 pi r8. For the time being, we will accept this formula. If we have time in the future, I will explain why did we get the formula. And now we add the two bases. The area for each base is pi r squared, and because we have two bases, so we double it to get 2 pi r squared. So we have the formula for the total surface area of the cylinder as 2 pi r8 plus 2 pi r squared. Try to remember this because you're gonna apply this in the next line. Okay, now we go to the example. Calculate the area of the following cylinder. Here we have a cylinder of the height 12 centimeters and the base radius of 8 centimeters. So now please apply the formula I have shown you earlier to find the area for this surface. Pause this video and try to find your answer yourself before check the answer with mine. Again, the formula is 2 pi r8 plus 2 pi r squared. And now we substitute the numbers into the formula to get 2 pi times 8 times 12 plus 2 pi times 8 squared. And after reducing it, we have 330 pi. And if you want to convert it into normal decimal number, then we will have 1005.3 square centimeters. And that is the answer for the surface area of this cylinder. Have you all got the answer correctly? Good. Now we are moving on to the next shape, a sphere. I bet that a sphere is very familiar to you. Everyone has some objects shaped like spheres in your house. Can you think of any sphere object in your house right now? Okay, so we have the most important sphere, it is the Earth, I believe. Our Earth is shaped like a sphere, and like the stars, the planets, they are all spheres. And next we have ball. A ball is the most common example of the sphere. You can see most balls are shaped like spheres. Basketball, the ball in soccer, the ball in tennis, table tennis. But the football, the American football ball is not sphere. It is uh, a bit oval, a bit oval. And finally, we have marbles. Marbles are a small, sparkling, colorful sphere that we used to collect when we were a kid. Okay. Again, we will have a look at the anatomy of a sphere. This is my drawing of a sphere. We have the center, a point that lies inside the sphere that like it has the distance to any point of the outer sphere equal to other distances. And the great circle is a circle, the greatest circle possibly drawn on the sphere, and it will it passes through the center of the sphere. Just imagine a perfectly round orange. You have a perfectly round orange, and the you cut the orange into perfectly equal half. Then you will expose the surface of your cut will be exposed, and it looks like a circle. That is the great circle. And of course, we have the radius. The radius of the great circle is exactly the radius of the sphere. Now we will come to the area of the sphere. Simply 4 pi r squared. Easy to remember, right? 4 pi r squared. Again, we will not prove this. 4 pi r squared. Now here's the example. Calculate the area of the following sphere, a sphere whose radius is 4.5 kilometers. That is an enormous sphere, maybe like a small planet, an asteroid. Okay, pause this video and find the answer yourself first. Okay, have you got the answer yet? A is equal to 4 pi r squared, and in this case it is 4.5 squared, and it is 81 pi. 81 pi is approximately 254.5 square kilometers. Huge area, right? We can plant a lot of corn on that. And finally, the last shape in today's lesson is going to be a cone. Okay, a cone. Can you think of any object in real life that you call a cone? It's often shaped like a mathematical skull, mathematical cone. And here are some examples for the cones. The ice cream cone, of course, the Vietnamese hat, and the traffic cone. Can you picture a cone now? Can you think of any objects that are shaped like a cone? Now let's come to the anatomy. We have a circular base, and an apex. An apex. An apex lies on the axis that rises from the center of the base and perpendicular to the base. So the 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 path, the axis that comes from the apex to the center of the base is perpendicular to any radius of the base. And we have the curved surface, the curved surface, the base, the radius, and the slant height. The slant height is the height from the apex that goes to one of the point on the outer of the base, the circular of the base. Can you see that? From the apex to a point on the outer of the circular base. And we have the area. Again, a cone can be divided into two parts, the curved surface and the circular base. And the formula for the curved surface is pi rs. The formula for the circular base is pi r squared. So combine them together, we will have the pi rs plus pi r squared as the area for a cone. Try to remember this before we come to the next slide. Got it? Example, calculate the area of the following cone. Here we have a cone of the radius 6 meters and the slant height of 10 meters. Okay, try to apply the formula that I have shown you and work out your answer. Now let's see my answer, shall we? The area is equal to pi rs plus pi r squared equals to pi times 6 times 10 plus pi times 6 squared, and that should be equal to 96 pi. 96 pi. That is equal to 301.6 square meters. Now the next section is going to be the practice section. Exercise number 1. Calculate the area of the solid below. Here we have a sphere, but cut in half. We take only half of the sphere, and we have a lid, which is a circle on the top. It is like a lid for the sphere. Again, I suggest pausing the video and try to solve this problem on your own first. Okay, have you got the answer? Let's check it. The area of the solid is equal to the base plus the hemisphere. The area of the base is simply this area of a circle. Pi times r squared, pi times 3 squared, plus 1, because we have only half of the sphere, so we take 1 over 2 times 4 pi 3 squared. And after the simple calculation, we can convert it into 27 pi, approximately 84.8 square centimeters. Am I moving too fast? Hopefully you don't have to watch this video in 0.5 speed. Okay, now we move on to the next exercise. Calculate the surface area of the solid below. Here we are given the normal cone, but we are not given the slant height of it, but instead we were given the actual height of the cone. The height of the cone, the distance from the apex to the base. Now let's see the answer. As I have mentioned earlier, the height and the radius and the slant height form a right triangle. And in a right triangle, we can always find the help from Pythagoras. We have the Pythagoras theorem. S squared equals 5 squared plus 2 squared. So S is equivalent to the square root of 29. Now we have found S. Apply into the formula. The surface area of the cone is A is equal to pi rs plus pi r squared equals pi times 2 times square root of 29 plus pi times uh, 2 to the power of 2. And that should be approximately 46 times 46.4 square meters. Okay, have you got the answer correctly? Now moving on to the next one. Exercise 3. Here we have an ice cream cone with both the cone part and the ice cream part. The ice cream part is actually a hemisphere or a half of a sphere. Okay, hopefully you have found the answer on your own. The surface area of the hemisphere is calculated as 1 over 2 times the area of the sphere, which is 4 pi 2 squared. So the result is 8 pi. The surface area of the cone is pi times 2 times 6 is equal to 12 pi. And now in order to find the area of the solid, we only have to add them together to find the answer of 20 pi. 20 pi. You can convert it into decimal number if you want to. It will fall somewhere between 60, 68, no, 62 to 70. If you have any question or if there's anything you want me to explain further, just leave it in the comment section. Now exercise number 4. Calculate the surface area of the solid below. This solid is this solid can be broken into two parts, the body part and the lid part. The body part is like a cuboid, and the lid part is actually half of a cylinder. Okay, try to think of the answer yourself first before checking my answer. Okay, so first we have to calculate the surfaces individually and then we add them together because this shape is complicated and we do not have a single formula to find directly the area of this. So first we will try to find the area of the base. 12 times 6 equals 72 square meters. I mean the rectangular base, not the base of a cylinder on the lid. The area of the side faces. The side faces. Actually, there are two pairs of side faces. Two pair, two pairs of identical rectangles. So the first pair is 2 times 6 times 2, and the second pair is 2 times 12 times 2 equals 72 square meters. So now we have calculated the wall surrounding the four side faces. Now we come to the area of the lid. The area of the lid is half the area of the full cylinder. So the trick is to find the base radius of this cylinder. It is not given, but you can figure it out quite easily. That is the trick in this problem. Okay, now have you found the radius yet? The radius of the cylinder. It is 6 divided by 2 equals 3 meters. So apply the formula for the surface area of the cylinder. We have 2 pi r squared plus 2 pi r8. And then we take 1 over 2 of it because we have only half of the cylinder. So the answer is going to be 45 pi. The calculation is like as shown on the screen. You can check it. Of course, I can make some mistakes somewhere, and if I do have some mistakes, just not comment it in the comment section. And in order to find the surface area of the solid, we just add all those areas we have calculated together. We have 72 pi plus 72 pi plus 45 pi, and that is approximately 285.4 square meters. Hopefully you all have the same answer as mine. Okay, do you have you finished this problem? Okay, so that's it for today. Today I have introduced to you three solids: the cylinder, the sphere, and the cone. At home, I expect you to review the lesson, learn by heart all the formulas for the surface areas of cylinder, cone, and surface and sphere. Prepare for the practice lesson next week. Okay, and that's it for today. See you next week. Goodbye now.